This is Academic Decathlon for Mathematics. We are working on worksheet number 10. We're going to do a little geometry now. So we're going to talk about transformations of points. So if we take this original point, this is our warm-up, if we take our original point and we transform, meaning we apply this rule to my x value and we apply this rule to my y value, that will produce the transforming point. So we're going to take this and we're going to take 3 times my x value will be my new x value, and 2 times my y value will be my new y value. So my new coordinate is going to be 15, 4. That is how it transforms to that, utilizing that rule. So we'll do that again. We will take the x value and we're going to plug that in, so -7 plus 2. And then we're going to take our y value and we're going to plug in that, so that's 1 minus 3. So we get the point or the coordinate -5, -2 would be our new value. Our what would we call it? Prime value, I think is what they call it. So using this rule, we have -8 minus 10, -2 plus 7, and that gives us -18, 5. So that's nice and easy, and we call that, so we do call it congruency in geometry. Triangle DEF has coordinates D of -3, -2, E of 0, 5, F of -5, 5. It has undergone some changes, and a triangle was produced at D prime. We call that D prime with that exclamation point. D prime of 4, -5. So we can do this RDEF and D prime, E prime, F prime congruent. So there's a number of things we can do. We can find the slope, but some changes. So we have 3 types. You have a shift, you have a dilation, and you have a rotation. So we have to be careful. So let's, all these are within a normal coordinate plane. So let's just plot this in a coordinate plane. That's going to be our easiest way to do this is, hey, let's just plot them. So we'll do this in green. We'll do the D, so -3, 1, 2, 3, -2. That's going to be my D point. 0, 5, 1, 2, 3, 4, 5. Okay. And then we have -5, 5. So 3, 4, 5. 1, 2, 3, 4, 5. So that's my object. And we can draw, we can connect the dots so we can see what our object looks like. And we see that it looks very similar to an isosceles triangle. And now we're going to take this one and we're going to do this in blue. So 4, -5, 1, 2, 3, 4, 5. Sorry, 4, -5, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, that is going to be D prime. So this was D, and this is going to be D prime. And 7, 2, 1, 2, 3, 4, 5, 6, 7, 1, 2. Okay, that's going to be E prime. And I would assume that this is E. And F prime is 2, 2, 2, 2. And also still looks very true to its shape. We'd have to count the distance to make sure that it hasn't expanded any. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The length from F to E is the same as F prime to E. So are they congruent? They look like they are 1, 2, 1, 2, 3. So it is 2 away. Is this 2 and then 3? Yes. Is the distance 1, 2, 3, 4, 5, 6, 7? 1, 2, 3, 4, 5, 6, 7. Yes, they're congruent. They've just been shifted. They've been shifted. We want to talk about the shift. You can say x, y changes from, so what did we do? We added 1, 2, 3, 4, 5, wait, 1, 2, 3, 4, 5, 6, 7. X was plus 7 and y was minus 2 for every point. That was what we did. It was a shift, horizontal and vertical shift. Cool. So, but yes, they are congruent. But sometimes they ask you, what is the transformation? I think is the term they use. All right, what is the equation of the line connecting? Yes, all right, so that is it. I didn't see that that was the question. Yes, all, and yep, it is x plus 7, y minus 3 is the transformation. What is the line connecting? Oh, so yeah, so we did need that. But what is the line connecting D to D prime? Sorry. Okay, what is the line connecting D to D prime? So what they're asking is, hey, if we make a line here, if we connect these dots, we connect them, and we have to write an equation for that. So how do we do that? There's a number of ways we can do it. We can look at those 2 points, the 2 D points, which is -3, -2, -3, -2, and this is what we just worked on in class, and 4, -5, 4, -5. So we find the slope. Number 1 is find slope. So we're going to do -5 minus -2. We're going to do 4 minus -3, and that gives us -3/7. That's my slope. And now I can use point slope. Why didn't I use slope intercept? Because I'm not provided the intercept. I'm provided a point. So we'll say y minus -5 equals my slope, -3/7 times quantity x minus 4. And now I'm going to simplify. So this becomes y plus 5 equals -3/7 x plus 12/7, and then we're going to minus the 5 over. We could have left it like this, you know, simplifying in point slope. That's a linear equation, but I think they want it in slope intercept form. This is going to be -35/7, and that gives us -23/7. Is that the equation? No. That is not the equation. Why is that not the equation? What did I do wrong? -5 minus -2. That's -5 plus 2, which is -3. Then we do 4 minus -3, which is 7. That should be -3/7. And then we have our x value minus, yes, and that's correct. That's positive. That's minus, and 12/7. Yeah, this is the line. I mean, this answer key, whoever makes these answer keys are really, really bad. So the equation is y equals -3/7 x minus 2/3/7. I mean, I might need to be in charge of checking. I mean, take the time to do it. What are you doing, answer key people? Triangle DEF. What is the line connecting E to A? Well, you would assume that it's going to have the same slope because it's going to have the same change. Oh, that was not 2, Mr. Mac. First of all, I made 1 mistake there. 1, 2, 3. That one should be -3. Okay, we make mistakes, yes. But notice when we check our work, so it's going to be parallel to this line, right? If we look at E, it's still going to be parallel because it's going to have the same change from point to point, transformation, should we say. It's just going to cross the y-axis differently. And we know where the y-axis is because in this line, my E has a y-intercept, so it's 5. So I can automatically right. I don't have to do any calculations. I know it's going to be y equals negative 3/7 x plus 5 because the y-intercept is 5. So that was really easy. That one they did get right. And then f. Did I just do the wrong one? Did I not do d? I did d. Did I not write down the d values? Negative 3, negative 2, 4, negative 5. Yeah, I did this correct. I don't know why. All right, now if we're going to do the f values, we're going to take negative 5, 5, and 2, 2. Now, it doesn't matter which one. We know the slope's still going to be the same. So if we use point slope, we can use y minus 5 equals negative 3/7 times x minus negative 5. So y minus 5 equals negative 3/7 x. That's going to be plus, and that makes negative 15/7. And we will add 5, which is 35/7. Right? Did I? Okay, I did. Plus 35. Oh, yeah, because that was different. All right, that's okay. Good, good. I'm just checking. I still always am open to me making a mistake. That's going to be plus 20/7. And that's the answer they got. Yeah, so look at number 2A, or 2. I think that's wrong. All right, number 5. What do you notice about the lines if you found in numbers 1 through same slope? Yeah, slope, because they're being shifted the same. They have the same slope, different y-intercepts, meaning they are parallel. Yes. Number 4, and again, notice we're actually on number 6. Academic decathlon. Quadrilateral A, B, C, D has undergone transformation to produce. Are these two quadrilaterals congruent? So what we can do is, here's the other thing we can do, is we can look at the transformation from 5, 2 to its prime value. So what did we do? Well, we stayed on the same y. All we did was move along the x. So that transformation was, hey, we're going to subtract 10 and we keep the y value. Is that consistent for all the points? If we plug in, this is A to A prime. So if we plug in B, which is 5, negative 2, does it, if we use this transformation, does this become negative 5, negative 2? Yes, that's good. So that one transformed. So let's do C. So C is negative 3, 2. Let's put it in the transformation. Let's subtract 10. So does it become negative 13, 2? Does C prime equal this? This is B prime is correct. So no, that's a no. That does not equal. We should be going down. And let's look at D. D is negative 3, negative 2. And if we put it through there, that becomes negative 13, negative 2. And that also is incorrect. So that is, are these two quadrilaterals congruent? Well, they're congruent. Well, could they have rotated it? Could they have rotated it? Points are reflected across the y-axis. All lengths have been maintained. All right, so that's very interesting. So we did not rotate. Okay. All right, so I mean, I guess we got to draw it, right? And then look at the object. So we're gonna duplicate this. So that was a mistake in how we should evaluate it. So maybe there is just a value of plotting them on the same. So we'll do A in green, 5, 2, 1, 2, 3, 4, 5, 1, 2. This is going to be A. B is 5, -2. C is -3, 1, 2, 3, 2. Okay. And D is -3, -2. Okay, now that, right, notice the difference of perspective. I have a much better understanding of this quadrilateral now. And now let's take it and go -5, 2 for my prime. -5, 1, 2, 3, 4, 5, 2. Okay, that is going to be A prime. -5, -2. That's B prime. 3, 1, 2, 3, 2, which is C prime, and 3, -2, which is D prime. So yeah, it's a little bit different. So we reflect it. We are going to draw that to that to that to that. So it is flipped, and no, it's just reflected because it is 1, 2, 3 to the left, 1, 2, 3 to the right. So we just reflected it over this axis of symmetry. Let's do this. So what was that axis of symmetry? So if we take the difference between that, is it along the x-axis? Yeah, right? Or the y-axis. So we just reflected it over the y-axis because that 3 now becomes this 3 becomes this 3. So are they congruent? Yes, they are congruent. Yes. All right. So let's draw. We see that drawing is better than trying to find a shortcut mathematically. So has it undergone a transformation to produce? Are they congruent? So let's stick to our guns. Let's keep doing what worked for us. So G is 3, 4, 1, 2, 3, 1, 2, 3, 4. The only reason I don't want to draw is because it takes some time, but I guess I shouldn't be afraid of investing. 1, 2, 3, 4, 1. So this is G, this is H, I is -1, 2, J is -2, 6, 1, 2, 3, 4, 5, 6. Okay, this is an interesting object. It's interesting because it didn't go G, H, I, J. Okay, G to H to I to J. Oh, it's a parallelogram. Okay, yep. That slope from G to H is left 1 up 3. I to J is left 1 up 3. Let's find its new is -2, 6, which is here. That is going to be G prime, which is on top of J. H is -3, 1, 2, 3, 3, 1, 2, 3. Okay, that is H prime. -6, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Oh, I see where you're going. I prime, and J is -9, 8, 1, 2, 3, 4, 5, 6, 7, 8. That looks a little goofy. That point seems to be the one that's out of whack. You were so good up until then. So if we go G to H, whoa, why didn't that draw? Do blue. G to H, H to I to J, and then J back to G. So let's label that J prime. So no, they are not congruent. You kind of thought that maybe it was going to be flipped or rotated a little bit, but not the case. No, not congruent. All right. Yeah, they do not. All right. So good worksheet. I like that. Those geometry, the transformations are really important and super fun. So good luck. There are the answers to the problems. Have a great day.